Today we're going to go over the functions that you have learned throughout your high school career. There's a back side and a front side, and we're going to start with the side that says y equals x. We're going to start by naming each function, and then after we name it, we're going to graph them. So this function right here to my first function right here is called a linear function, but it's also known as the identity function. And the reason we call it the identity function is because every x equals every y. So which means we have a point at 1, 1, we have a point at 0, 0, and we have a point at negative 1, negative 1. And because it's linear, it makes a straight line that goes through all 3 points. So now that we have our graph, we can answer the questions that they're asking. They want to know the domain and the range. This graph has a domain that goes from negative infinity to positive infinity. Its range also goes from negative infinity to positive infinity. There are no holes or asymptotes in the graph, so it's continuous. It's increasing from negative infinity to positive infinity, and it doesn't decrease at all. It has symmetry across the origin, which means it's an odd function. The second function we see is called our square function. In Algebra 1 and Algebra 2, you also called it a quadratic. The graph of the square function goes through the point 0, 0. If 1 is squared, we get 1. If negative 1 is squared, we get positive 1. If 2 is squared, we get 4. And if negative 2 is squared, we also get 4. So we get a U-shaped graph. It's called a parabola. The domain for this function is also negative infinity to positive infinity. The range for this particular function, the lowest point is 0, and 0 is included, up to positive infinity. This graph is also continuous. There are no holes, there are no asymptotes. It's going to increase from 0 to infinity, and it's going to decrease from negative infinity to 0. This is symmetric about the y-axis, so it is an even function. The third function is called our reciprocal function. The reciprocal function has a point at 1, 1 and has a point at negative 1, negative 1. It's asymptotic about the y and x-axis. The domain for this graph is going to be from negative infinity to 0, not including 0 because we can't divide by 0, union 0 to positive infinity. The range is going to be exactly the same thing, negative infinity to 0, union 0 to positive infinity. Because it is asymptotic, it's discontinuous this time. It doesn't increase at all, it only decreases. It decreases from negative infinity to 0, union 0 to infinity. It's symmetric about the origin, so it's an odd function. The fourth function is called the reciprocal squared. It's very similar to the reciprocal function, except because it's squared, everything that was down here in quadrant 3 is now going to be up here in quadrant 2. So it's still going to be asymptotic to the x and the y axis, but they're both going to go up. Okay, so our domain, again, it's going to go from negative infinity to 0, union, because we're not including the 0, and from 0 to positive infinity. Now my range doesn't include anything down here, so my range is going to go from 0, but not including 0, to positive infinity. Again, it's discontinuous because we have asymptotic behavior. This one is going to increase from negative infinity to 0, but it's going to decrease from 0 to infinity. This is symmetric about the y-axis, therefore it is even. Okay. The next function we have is called your absolute value function. Absolute value. An absolute value means how far you are from 0. So when you go graph this, 0 is 0 from 0, 1 is 1 from 0, 2 is 2 from 0, negative 1 is also 1 from 0, and negative 2 also has a distance of 2 from 0. So it looks a lot like a parabola, except it's more V-shaped. We're not squaring anything. All right, so our domain is going to go from negative infinity to positive infinity. Our range is going to go from 0, and this time I'm including my 0, to positive infinity. There's no holes, there's no asymptotic behavior, so it's continuous. We're going to increase from the turning point from 0 to infinity, and we're going to decrease from negative infinity to 0. It's symmetric about the y-axis, therefore it is even. Our next function is the square root function. Okay, and the square root function looks like this. The square root of 0 is 0. The square root of 1 is 1. Your next perfect square is 4, and the square root of 4 is 2. It curves like this. Okay? So the domain for this one goes from 0, including 0, to infinity. Your range goes from 0 to infinity. There's no holes, there's no asymptotes, so it's continuous. It never decreases, it only increases, and it increases from 0 to infinity. There's no decreasing. It's not symmetric about the y, it's not symmetric about the origin, it's none. And because it has no symmetry, it's neither even nor odd. The last one on the front is called our cube root function. Cube root. Okay. The cube root of 1 is 1. Your next perfect cubed is 8, and the cube root of 8 is 2. The cube root of 0 is 0. The cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So it kind of looks like this. Okay, it needs to be a little bit flatter probably. So your domain is from negative infinity to positive infinity. Your range, again, is negative infinity to positive infinity. There's no holes, there's no asymptotic behavior, so it's continuous. This is only increasing, no decrease, from negative infinity to positive infinity. It's symmetric about the origin, so therefore it is odd. Okay, so these are the parent functions for the first half of the worksheet. Let's go look at the back. So on the back, the first one we have is called our log function. It's called our log function. And the log function goes through 1, 0, and 10, 1. And it is asymptotic to the y-axis. The domain is going to go from 0, but it can't include 0, to infinity. Your range, it goes up and down forever. So it's going to go from negative infinity to positive infinity. This piece of the graph is continuous. Even though it's asymptotic to this axis, it still goes on forever. There's no holes in the piece that we graphed. The interval of increase is from 0 to infinity. It does not decrease. It is not symmetric about the x or the y or the origin. Therefore, it is neither odd nor even. Our next function is called our exponential function. And we're using a base of 2 for this particular one. So when you do your graph, 2 to the 0 power is 1. 2 to the first power is 2. It's going to go up like this, and then it's going to get really, 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 really close to the x. So your domain is going to go from negative infinity to positive infinity. Your range, you're always going to be above 0. It's going to be 0 to positive infinity. It's only continuous because there's no holes. It is only increasing from negative infinity to positive infinity. It has no symmetry, so it's neither odd nor even. All right. The next one is called our cube function. Some people call it a cubic, but it's also called the cube. Okay. 0 cubed is 0. 1 to the third is 1. 2 to the third is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Negative 1 to the third is negative 1. And negative 2 to the third is negative 8. 2, 4, 5, 6, 7, 8. Okay, so it's going to look like this. It kind of goes up really close to the y. So our domain for this one, again, is negative infinity to positive infinity. My range is negative infinity to positive infinity. It is continuous. It's only increasing. It is symmetric about the origin, which makes it an odd function. The last three that we're going to go over are ones that we actually covered this year in class. This one is our sine function. And when we learned how to graph these, we said that we were going to, sine was like the original sin. So it started through the origin. And we divided our sections of our graph into 2 pi, and then we halved it, halved it, halved it. And we said, okay, we're going to start at the origin, we're going to come up to the max, cut the axis, down to the minimum, back to the axis, and it looked like this. And it went on forever in both directions. So since it goes on forever in both directions, our domain actually goes from negative infinity to positive infinity. But our range only went from negative 1 to positive 1, inclusive. These are 2 brackets. It is continuous. And we're not going to talk about the intervals of increasing and decreasing. We're going to talk about our fundamental period. And the fundamental period for sine is 2 pi. It's symmetric about the origin, so it's an odd function. Then we have our cosine function. And our cosine function, again, we're going to get 2 pi, pi, half it, 1, and negative 1. Okay, so cosine started at the max, cut the axis, minimum, axis, max. And it kind of looked like the tulip. Always called it the tulip. So the domain goes from negative infinity to positive infinity. My range is from negative 1 to positive 1. It is continuous. The fundamental period is 2 pi. It's symmetric about the y-axis, and it's even. And the very last one is our tangent graph. Tangent had asymptotes at pi over 2 and at negative pi over 2. It touched the origin and the right arm went up and the left arm went down. So the domain for this one was really tricky. It was everything except for intervals of pi over 2. When you wrote it like this, x cannot equal pi over 2 plus pi in, this means intervals of pi, so every time, pi over 2 plus pi, so another cycle, where n is an element of the integers. We went from negative infinity to positive infinity. We were discontinuous because we had asymptotes. The fundamental period is not 2 pi. It's actually pi. It's symmetric about the origin, so it is odd. You will need to be able to identify all of these by looking at a graph with the name. You will also need to be able to sketch pictures of these in order to do transformations, which we will be doing on Thursday in class and on Friday with your assessment. Please study the names, the equations, and the graphs. Good luck!